Hello children. In the first part of chapter 1, chemical reactions and equations, you have learnt about chemical reactions, chemical equations and balancing of chemical equations. In this presentation, we are going to discuss two topics. First, balancing of chemical equations, few more examples. Second, types of chemical reactions, and we will be only discussing these two types, combination and decomposition reaction, in this presentation. So let us take few examples. First, there is the first example. When hydrogen reacts with chlorine, we get hydrogen chloride. So first of all, we have to write the skeletal equation, which means unbalanced chemical equation. Next, we make a list of elements on both sides of equation, and we see that both hydrogen and chlorine are not equal. So to balance hydrogen atoms on both the sides, we multiply HCl by 2 and we get H2 plus Cl2 gives 2HCl. And chlorine atoms are automatically balanced. So we check the correctness of balanced equation and we found that on both the sides the atoms of hydrogen and chlorine are equal. So the balanced chemical equation is H2 plus Cl2 gives 2HCl. Now let us take another example. When barium chloride reacts with aluminium sulfate to give barium sulfate and aluminium chloride. First of all, we'll write the skeletal equation. BaCl2 plus Al2SO4 whole thrice gives BaSO4 plus AlCl3. We'll make the list of elements and we found that all the atoms are unequal. So we will select the biggest formula and start balancing. The biggest formula is aluminium sulfate. So to balance aluminium atoms, we multiply AlCl3 by 2, and to balance sulfur atoms, we multiply BaSO4 by 3 on right hand side and we get this equation. Now oxygen atoms are automatically balanced. To balance barium atoms, we multiply barium chloride by 3 on left hand side and we get this equation, and chlorine atoms are automatically balanced. Now we will check the correctness of balanced equation and we found that all the atoms on both the sides are equal, so the balanced chemical equation is given below. Now this is the third example. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. First of all, we'll write the skeletal equation and then we'll make the list, and we found that hydrogen and sulfur are already balanced. So to balance oxygen atoms, we multiply O2 by 3 on left hand side and H2O and SO2 by 2 on right hand side, and we get equation like this: H2S plus 3O2 gives 2H2O plus 2SO2. Now to balance hydrogen atoms, we multiply H2S on left hand side by 2 and we get this equation. And we check the correctness of equation and we found that on both the sides these atoms are equal. So the balanced chemical equation is given below. Now we take the fourth example. Potassium plus water gives potassium hydroxide plus hydrogen. First of all, we'll write the skeletal equation. Potassium plus water gives KOH plus H2. We make the list of elements and we found that potassium and oxygen atoms are already balanced. So to balance hydrogen atoms, we multiply KOH by 2 on right hand side and we multiply H2O by 2 on left hand side. We get this equation. And to rebalance potassium atoms, we multiply K by 2 on left hand side and we get 2K plus 2H2O gives 2KOH plus H2, and we check the correctness of balanced equation and we found that all the atoms are equal on both the sides. So finally the balanced chemical equation is given below. Now this is the fifth and the last equation, and here we will balance this equation in a different way. After writing the skeletal equation, we will write the coefficients A, B, C and D in front of the symbols and formulae as shown in the equation. Next, we will compare all the atoms on left hand side and right hand side, and we found that for aluminium A is equal to C, for copper B is equal to D, and for chlorine 2B equals to 3C. Now we have to assume any one of the coefficients A, B, C or D as 1. Let us take A equals to 1. If A equals to 1, C is also equal to 1. And 2B equals to 3C. It means B equals to 3 by 2. Since B equals to D, D is also equal to 3 by 2. So we get, but we don't want the answers in fractions. So we multiply all by 2 and we get A equals to 2, B equals to 3, C equals to 2 and D equals to 3. So the balanced chemical equation is 2Al plus 3CuCl2 gives 2AlCl3 plus 3Cu. I have explained two methods of balancing. Whichever you like, you can use and balance the chemical equations. Now we will discuss the types of chemical reactions. There are 5 main types of reactions, but we will discuss only the first 2. So the first is combination reaction. The chemical reaction in which 2 or more substances, it may be an element or a compound, when they combine together to form a single compound, we call it as a combination reaction. You can, as shown in the figure, when A combines with B, we get AB. Now these combination reactions are of 3 types. It can be between 2 elements, it can be between an element and a compound, and it can be between 2 compounds. So we will see this one by one. So these are the 3 examples of combination reaction between 2 elements. So element combines with element to give compound. Carbon reacts with oxygen to give carbon dioxide. Magnesium reacts with oxygen to give magnesium oxide, MgO. Hydrogen reacts with oxygen to give water. Now this is burning of magnesium reban. This is activity 1.1. So before burning magnesium reban, we must clean it with sandpaper to remove a layer of magnesium oxide. So when we burn it, what observation we get? Magnesium reban burns with a dazzling white light and changes into a white powder. So it means it burns in air to combine with oxygen to form magnesium oxide as shown in the equation. The combination reaction in which a compound is formed from its constituent elements is known as synthesis reaction. So all the reactions which we have discussed till now are also known as synthesis reaction. One more example is given below. Sodium reacts with chlorine to give sodium chloride. Now this is the second type of reaction in which an element combines with a compound to give another compound. So carbon monoxide reacts with oxygen to give carbon dioxide. Sulfur dioxide reacts with oxygen to give sulfur trioxide. Nitric oxide reacts with oxygen to give nitrogen dioxide. Now we have third type between 2 compounds. Like calcium oxide reacts with carbon dioxide to give calcium carbonate. Calcium oxide reacts with water to give calcium hydroxide. Ammonia reacts with hydrochloric acid HCl to give ammonium chloride. Now this is an activity 1.4 in which reaction of water with quicklime is shown. So when water is added to the quicklime, the reaction becomes very vigorous, means a large amount of energy is produced, and the reaction is known as exothermic, highly exothermic, along with the formation of slacked lime, which is shown in the equation. Next we have decomposition reaction. So the chemical reaction in which a single compound breaks down to form 2 or more simple substances in the presence of heat, light or electricity is known as decomposition reaction. As shown in the figure, AB breaks down into A plus B. There are 3 types of decomposition reaction: thermal decomposition reaction, electrolysis, photochemical decomposition, or photolysis. We'll see one by one. Thermal decomposition, the decomposition reaction taking place on heating is known as thermal decomposition reaction. One example is shown here. When calcium carbonate is heated, calcium oxide plus carbon dioxide is formed, which is shown in the figure also. Calcium carbonate is heated, CO2 is formed, a burning matchstick is brought near the mouth of the delivery tube and it is put off because carbon dioxide is not a supporter of combustion. This is another example of thermal decomposition reaction in which we are heating ferrous sulfate crystals. So when we heat ferrous sulfate crystals, first we observe that it is losing water molecules, and then on further heating it decomposes to form a reddish brown residue along with the evolution of gases. So the reddish brown residue is ferric oxide and the gases evolved are sulfur dioxide and sulfur trioxide as shown in the equations. This is another example of decomposition reaction, thermal decomposition, heating of lead nitrate crystals. So when we heat lead nitrate crystals, we observe brown fumes and a yellow residue is left in the test tube. So the brown fumes are nitrogen dioxide NO2 and the yellow residue is lead oxide. The equation is shown below. Now we have the next type, electrolysis. Decomposition reaction which takes place when electric current is passed through the compound in molten state or in aqueous state is known as electrolysis. The word electro means electricity and lysis means breaking. So this activity 1.7 is showing electrolysis of water. In this activity, two electrodes, anode and cathode, which are made up of graphite, are connected to a battery. These two electrodes are attached to a mug having water. A little concentrated sulfuric acid is added to the water to make it conducting. When current is passed through it, bubbles are formed at both the electrodes, which shows the formation of gases. We take out the test tubes carefully. The gases formed are hydrogen and oxygen, which is confirmed by bringing a burning matchstick near the mouth of test tube. Hydrogen gas burns with a pop sound and oxygen gas supports burning. Now they are formed in the ratio of 2:1 by volume as shown in the balanced chemical equation. Now this is another example, electrolysis of molten NaCl. We can see in the figure that when electricity is passed, sodium ions get deposited on cathode by gaining electrons and form sodium metal. Chloride ions lose electrons and forms chlorine gas at anode. The chemical equation is shown below. Next we have photochemical decomposition reaction. So the decomposition reaction taking place due to light, radiations or sunlight is known as photochemical decomposition or photolysis. We can see in activity 1.8 that a small amount of silver chloride is kept in a china dish in sunlight for few minutes, and we observe that white crystals of silver chloride turn gray in the sunlight, which means silver chloride decomposes into gray color and chlorine gas in the presence of sunlight as shown in the equation. Now this is another example where silver bromide forms silver and bromine gas in presence of sunlight. Now these two reactions, both these equations are used in black and white photography. Hydrogen peroxide, it is also decomposed in sunlight, decomposes in sunlight to form water and oxygen. So they are kept in colored bottles. Now we come to the conclusion of this chapter. Balancing of chemical equation is done to satisfy the law of conservation of mass. In combination reaction, we can see only one product is there, so it is very easy to identify. In decomposition reaction, we have only one reactant, so it is also very easy to identify. All decomposition reactions are endothermic reactions. Combination reactions are generally exothermic. Combination reactions are opposite of decomposition reactions. So children, we come to an end of this presentation. I hope all of you must have understood the topics properly, but still if you have doubts, you are free to ask. The remaining part of the chapter will be discussed in part 3 of the chapter.